What's up, guys? In this video, I'm going to talk about bar graphs versus segmented bar graphs versus mosaic plots versus two-way tables. So the big gist of this video is we're looking at categorical data, okay? Categorical data and just all the different ways we can represent it. Now, some of these graphs, the first two, I think are stuff that most students have seen before. They understand them. It's the second two, more the mosaic plot, or the back two, mosaic plot and the two-way tables that are a little bit kind of fresh. So I just kind of want to talk about those, make sure we understand them and how to read them. So in the problem that we have here, I said teachers and students were asked to identify their favorite math class. So they could have picked algebra, geometry, calculus, or statistics. So we just asked teachers, hey, what's your favorite math class? Students, what's your favorite math class? And I'm going to represent that same exact data 4 different ways, okay? So we asked them a categorical question there. We're recording algebra, geometry, calculus, and just counting up how many are there. So our first graph here is a basic bar graph. So across the side is our percentages. We have a little key here that says favorite math class. Dark blue is algebra. Then we have this light blue is geometry. Kind of a red is calculus, and then this kind of peach color is statistics. And we have 2 different bar breakdowns. We have students and teachers. So students and teachers, and our percentages up the side. So you can ask questions off of this like, hey, what across all groups, because these are all proportions, percentages, across all groups, what was the most common response? Like, what is the most popular response across all the groups? And that answer would be, well, the teachers, because we have the biggest bar here, the teachers who said calculus, that was the most common response. That hit 55%. So that proportion is largest, okay? So across everyone, since this was the largest bar, teachers who said calculus was the biggest proportion. If you wanted to kind of fine tune it and say, hey, only among the students, so among students only, what class is the most common? You could look kind of there just only at those bars. Our biggest bar there was statistics. So among students, they said statistics at 50% was the most common. Could go the opposite way. Students' least favorite class would have been geometry. Looks like for teachers, the least favorite class, smallest bar, is algebra. So that's a bar graph, which I feel like a lot of people have been exposed to. They see it, they get it. Wonderful, right? Then we kind of scale things up a little bit, and we can move into a segmented bar graph. Now in class, I kind of ask my students in class, let them think about it, I'd be like, hey, what do you think is the connection between this one and that one? But since this is a review video, I'll speed it up. Essentially what happens is you just take all these bars and just stack them up. So imagine if I took my students' algebra, geometry, calculus, and statistics bars, stacked them all up, you get this kind of big old bar here. And then do the same thing for teachers. So kind of what happens is the entire bar represents 100% of the responses. And then you kind of break down what chunk of the 100% goes to each of these categories, right? So, you know, we had students saying 50% of them saying statistics was the most popular. So of the total 100% for students, half of it, 50%, because they get 50 to 100, goes to students saying statistics is the most popular. And then you have your breakdown. I don't even remember what my exact number is. It looks like 30% for calculus, 5% for algebra, or no, geometry, and then 15% for algebras, because that's geometry and algebra. So you just kind of divvy up the 100% and break down for students, all right, what percentage goes to statistics, calculus, geometry, and algebra, and that's kind of what happened. We do the same thing with teachers, okay? So really, this is portraying the exact same thing as the above graph is. It's just shown just slightly different. We don't really get any new information from one to the other. It's just the visual representation is a little bit different. So if I would have asked, hey, across everyone, by proportion, what is the most popular response? You would just look for the biggest really bar. Now these two are super, super close, so you maybe have to, kind of look closely there. But what we know from above is this is 55%, this is 50%. So the answer is still the same. Teachers who said calculus is their favorite math class is by proportion the most common response. If you want to ask, hey, across students only, what was the smallest by proportion response? Students, the smallest part of this bar is the light blue, which is geometry. So students by proportion say geometry is the least popular. So that's a segmented bar graph. Again, those two aren't that different. It's the other two graphs that I think things get interesting, and they tell us a little bit more information, right? The one thing that this graph is hiding is, yeah, we know the percent breakdown of, who preferred stats, calculus, geometry, and algebra. We know that for the two groups. The only thing this graph is missing is it does not communicate how many students responded to this survey and how many teachers responded to this survey. As in every building, there's way more students in a building than teachers. So these are not really created equal. On a segmented bar graph, it really makes these two groups, students and teachers, look exactly the same. But as we know, they're not. And that's where mosaic plots or mosaic graphs come in. So here we go. Here is a mosaic graph. We're asking the exact same question. Hey, students, what's your favorite math class? Hey, teachers, what's your favorite math class? This is going to look very, very similar to my segmented bar graph. But what you should know is the width, how wide these bars are, has changed, okay? The different heights is exactly the same, okay? This is still going to span 50%, 30%, 5, and 15. The vertical spanning is the exact same as my segmented bar graph and my bar graph. What changed is the width. What a mosaic graph is going to do with the width is it's going to communicate, well, how many students responded to this versus how many teachers. So the fact that the students' bar is very, very, very wide and the teacher's bar is a little bit skinnier in comparison, what this tells us is the number of students that responded was far larger than the number of teachers that responded. So now, when I'm looking at everything as a whole and I just say, hey, what is the, by number, not so much proportion anymore, by number, like what is the most common answer here? What happened the most common? You're basically just looking at your size of these rectangles and looking at who has the largest rectangle. If you look at it, by width and height, this rectangle up here is by far the biggest. This is going to have the greatest number of responses in it. So this represents students who said statistics was their favorite class. So the number of respondents in this group is going to be the largest. Whereas proportions, if you want to do that, you can look at a segmented bar graph. So this is going to help you portray not only information about this category, but a mosaic graph is going to help you portray information about these categories as well. It hits two categories at the same time. So that is a visual representation of that data. Related to it is a two-way table. Now this two-way table I have here, I don't feel like it's the best because it has counts as well as percentages. Typically with what we deal with, we don't really have percentages, but it's fine. So this two-way table is portraying the exact same information as the mosaic graph did. It's just more of a numerical thing. So over here on the left side, I have my favorite math class breakdown, algebra, geometry, calculus, and statistics. Across the top is students and teachers. Students as teachers. And so how you read this is you can look at just different parts in the table. So if you want to look at this cell right here, this is where my algebra and students, my row of algebra and my column of students meets. There is 45 people that are students that said algebra is their favorite class. Fantastic. If you go, say, all the way over here, so my row is geometry, but my column is total. So in total, across my students and teachers, I had 45 people said geometry was their favorite class in total, and that's across students as teachers. It took all my students that said geometry, all my teachers that said geometry, added them together, okay? How this can connect to up top as well is, up top on the Mosaic graph, I said, hey, by number of people, what is the most common response? Well, if you look, there it is right there. That is my biggest count of people, 150 people. So I had students, 150, that said statistics was their favorite math class. So that is my most common response out of all of them because 150 is my biggest. I had 150 students say statistics was most popular. Last number I want to point out is this total row and column. That is all my totals of all students and all teachers added together. There's 400 of them. If you look across all your math classes, algebra, geometry, calculus, and statistics, you add up the totals for everyone, 400. So I have a grand total of 400 total people were broken down either algebra, geometry, calculus, statistics, as well as students and teachers. So that was a quick rundown of bar graphs versus segmented bar graphs versus mosaic plots versus two-way tables.